Sup everybody, Axe Wizard here, back with an update for my game Neurality 3092. I've done a few things. Let me just show you what I've got. When I hit play, don't panic. It's not going to show the game for a second or two yet. It's because I start the game in full screen, and then for some reason OBS takes a moment to track it. So give me just a second here. Okay, so you should be seeing the screen about now. So I did a few changes. One thing is fighters are much faster than they were. So fighters move at insane speeds now. The other change I did was I have a pause menu. So I can resume the game, I can exit game, I can go to options. For options, I've got a few basic options here. You can see that we are full screen. So if I uncheck this, the screen is going to revert to my normal background for a second, and then it should pop. It should come back on the screen in just a moment. So there we go. We are full screen, or not? We're no longer full screen. We're windowed like we were before, and everything should be showing up on the screen again. But if I go back in options and set it back to full screen, it should take a second for that to reflect. Should be on the screen now, I hope. But I also added a volume option. So I'm gonna set to like 30. And yeah. So those are the big changes I made. Fighters move much faster. So yeah, fighters, let's go down and take a look at our actual combat system so we can see how fighters work now. Because now that I sped them up, there's a few changes that need to happen. Oh, I also made it so you can't change the zoom while it's zooming in. I also need to lock the zoom when you're actually flying through space too, but I'll get to that eventually. So you can see that fighter is zooming away. Like, I can't catch him at all because I'm not a fighter. I'm technically a freighter with this little shuttle here. So I just felt that like all the ships were kind of moving at about the same speed. Before the ships were ranging anywhere between like 200 to like 500 pixels like per second is what their speed was basically, and it was kind of okay, but all the ships kind of felt like they just sort of moved the same, and it was really slow. So I made fighters a lot faster. So now fighters are going anywhere between like 700 to 1,000. So they are like double the speed of like anything else, and they are massively faster. So I think it's really cool. So you can see fighters are now actually picking off ships, and they're being a lot more annoying. But yeah, so those are the combat changes I made. Those are the big ones. The biggest changes was just the options menu and stuff here. So I can set the volume. That's a big thing. So now you can actually understand me when I'm showing off cool stuff, which I know for previous episodes, like that was a thing that was always a problem. Like I'd be blathering on about some cool stuff and nobody can understand me with all the explosions and lasers and shield effects. So now you can hopefully hear me. Woohoo! But yeah, let's go ahead and talk about these changes here. So all right, hold up. I forgot to talk about options. So while I was recording this, I completely blazed over, just didn't even talk about options. Let me talk about that really quick, and then we'll get back into the rest of the video. So for options, I created an auto load called options that has all of my global options that I want to set. For each of these variables, I declared a setter function here that will actually apply that option whenever this is updated. So for example, whenever I set full screen, it's going to apply that. So if we look at set full screen here, we're setting our value to we're setting our variable to equal that value, but then we're actually setting our operating system window full screen to be whatever that value is too. Same for borderless, same for VSync, and then for the master volume, that was something that I wasn't sure how to handle, but after looking at it, I use for my master volume variable, I have that set as a float that's expected to be from 0 to 1. So you can see that I initialize it at 0.8, which is about 80%. So on my ready function, I'm initializing that volume level. So what I'm doing here is how I'm setting the level is I'm calling audio server set bus volume dB, and I'm setting the master bus. And then Godot actually has a really handy function here called linear to dB. So I can set a linear value from 0 to 1, and it will set it to be the appropriate decibel level, because decimals are not linear like a volume slider is. So this allows me to set that smoothly. So whenever I set the actual audio server volume for the master bus, I'm always using that linear 2 dB conversion for my master volume. And then so in my setter down here, set master volume, I'm setting the master volume to equal the value, which will be anywhere between 0 and 1. And I have it stepified to like 0.01, so it's basically a percentage. And then whenever I set it, I'm just doing that linear 2 dB calculation. But anyway, I wanted to cover that really quick because I completely spaced it when I recorded it originally. So those are how I'm handling options here. It's probably not the best way, but it's the way that I'm doing. I have a to-do here to differentiate volume types. So when it comes time for that, I'm going to have to implement separate buses that are all underneath the master bus. And so that way you can control different volume types. So if I have, like, I don't know, voiceover dialogue maybe, or UI sound effects and stuff like that, you can differentiate those, so that way it's not just an all or nothing kind of thing. But for now, I'm just working with master volume because I only have one bus. So as far as the UI, I think I show that in the video coming up, but just in case I don't, it's just like for these booleans, I'm just using a checkbox type, and then for the master volume, I'm using a slider. So if we go to the options menu here, you can see that we have this volume slider here, and I have this set to be minimum value is 0, max value is 1. I have it stepified to only 2 decimal places, so that way it's basically going to be, you know, 0 to 1. It's not going to be like 0.5784315. It'll just be 0.58 or whatever it would round to. So and then I set the initial value to be that, whatever. It's also set in the code. And then to make it so that it sets those on the game launch. So in my options code, in my ready, which is called when it is actually auto-loaded, I'm initializing all those values. So I'm calling self.fullscreen equals fullscreen, so that it actually calls the setter function. So, and since it calls the setter function, it's actually updating that. So when I first start the game, it actually pops open full screen. Anyway, that's options. I missed that entirely. Back to the rest of the video. There was a big change I didn't add here. I should add it now, though, just so we have it here. Refactored how I handle UI. So, big thing how I did that is, let's go, we're already in my main node. So I had a function called setup space scene. And this is whenever you hit like new game, or whenever you leave a planet, or you enter a new system. It calls this, and it sets up the parallax background. It adds it to the scene, sets the sprite depending on what star system we're at, adds a bunch of other stuff, ships, the player ship, the camera, all that stuff. And then before, what I was doing when it was time to add the UI is I was manually creating a canvas layer. And then I was instancing my left panel UI, right panel UI, and I was adding it to that, and then I was adding all that there. And when it came time to implement like a pause functionality, that was all kind of chaotic and not well done. So I've been thinking about a YouTube comment that is probably going to have me refactor my whole ship code here, but they recommended I kind of break things down into smaller chunks, and I agree with that philosophy. So what I did was, for all of my UI, I just made a canvas UI scene. So if we go to my UI scenes here, boom. So we have canvas UI. So over here on the left, you can see that this is just a canvas layer type, a canvas layer node. And then I just added my right panel and left panel UIs just like I did before. So that didn't change. And I also added my pause menu and my options menu. So the thing that did change is that these are new and they're hidden by default. And now all that stuff is managed by just this one section here. So what I'm doing is I'm checking if I'm pressing escape. And then I got some logic here that could be better. But basically, what I'm doing is if I'm pressing escape, if I don't have any menu open, I want to show the pause menu. So I just have this case here like, hey, if we're not already paused and our pause menu is not visible, then that means that we want to pause the game and show the actual pause menu. So I'm using get tree paused. I'm setting that to be true, which is pausing the actual game. And I'm setting my pause menu to be visible. So that's basically just toggling this here. So pause menu here. So it just shows it there. Another thing I'm doing is this also hides these two when the game is paused. So I've got that working there. So one thing to know of one key important part of how this works is that on my root node here for Canvas UI, under pause mode, I've got it set to process. So that means that it's still running while the game is paused. For my right panel and left panel UIs, I have the pause mode set to stop because they shouldn't be doing anything when the game is paused. I don't think that they would be doing anything anyway because they would be set to be not visible, but I just set it to stop. And then these two during troubleshooting, I had it set to process. I should just set these back to inherit because that way they'll just go off of whatever I have Canvas UI set. I think that change should still work. So if we go here, the game should be visible now. I can go here. Yeah, so I can still change things while the game is paused. So yeah, that works. So let me exit and give it a second to show back up. So then for my pause menu, this is another scene. So both pause menu and options menu are separate scenes. So for pause menu, if we bring that up here, you can see I just have a center container. And I just have a VBox container. So that VBox container is centered in the screen just like you see here. So here's the center container, VBox container. And then inside that VBox container, it's got all these things layered or stacked on top of each other. So I've got my paused notification here saying, hey, you're paused. And then I have these buttons I made. These are not going to stay. I was just playing with how to style my own buttons and ignoring all the theme options that Godot has. So I need to revert these back to use actual buttons, and then I need to come up with actual usable themes to style things. So that will be eventually happening. But for now, I've got these buttons. So I've got resume, options, and exit. These are custom things that just emit a clicked signal. So I just hooked up that signal to my pause menu here, and I'm just emitting custom signals that go back up to my Canvas UI. So you can see in the ready function here, I'm connecting those signals to my own custom functions. And all those are doing is it's just opening options is just setting pause menu to be not visible, and then making options menu visible. Because we're already paused, we don't want to change that. Resume game is going to make sure that the game is no longer paused. It's going to turn pause menu to be invisible, and it's going to set right and left panel to be visible again. And then close options just sets the pause menu to become visible again, and just closes the options menu basically. So how I have that working is I have this unhandled input event here, and it's just checking if I pressed escape, which is a a input map that I set here. So we go to input map. You can see here escape. I have that set. So I just set that in my input map. Woohoo. So if we're pressing escape, then I have this sort of logic thing here. Just a if, else if statement. So I've got that going here. Actually, I could probably just change this to else, but it works, so I'm going to leave it. So what we're doing here is I'm saying, hey, we're pressing escape. Do we need to pause the game and display the pause menu? So what we're doing is we're checking to make sure that, hey, if the game is not already paused and pause menu is not visible, then that means that we want to display the pause menu and also pause the game. So we're doing that here. We're setting the get tree pause to be true, and we're also setting our visible property of our pause menu to be true. And we're also hiding right and left panel. So that's what we're doing there. The reason why we're doing that is because my minimap markers were showing up like over top of my pause menus or my options menu, which look weird. So then the next thing it's checking is, hey, if the game is paused and pause menu is visible and we hit escape, that means that we want to unpause the game and go back to it. So we are doing resume game, and that's that connector function I wrote down here that just sets it to be false. You know, it just sets paused to be false and also the pause menu to be no longer visible. Now, if the game is paused, but the options menu is visible when we press escape, then that means we want to go back to the pause menu. We don't want to just close it and then unpause the game. It might save a step, but it's not common behavior for that, and I think it might leave some question as to whether like changes actually took effect and stuff like that. So yeah. So what I'm doing here is I'm just saying I'm just doing the close options, which again just makes the pause menu to be visible again, and then just hides the options menu. So that's how I've got all that working. And yeah, so now I have all my UI stuff contained in just one scene here. I mean, there's other sub scenes, but it's all here and nicely wrapped up and yeah, contained. It does its own thing, and I don't have to worry about it. So all I have to do now is when in my main, when I'm setting up the space scene, adding UI is now 3 lines, and one of those lines is a comment. So yeah, fun stuff. I could probably even just condense this down into one line. I can just add child, and I can just cut this here and just add that there. But I like to be more explicit and have more readable code, so you can see that I'm explicitly making a UI, which is a canvas layer type here. And I'm loading that resource and I'm instancing it, and I'm adding that to my my main scene. So yeah, seems to work fairly well. But that's what I did there for UI. And now that I'm starting to feel a lot better with UI and like how it works, I just need to come up with a good theme. Because theming, I still don't understand how to do theming, and I don't know if I want to tackle that now or if I should just stop everything I'm doing and port this to Godot 4. Because I'm still using Godot 3.4. I'm not even using the latest version of the 3.x release. I think 3.6 is the latest Godot for version 3. But I kind of want to update to version 4. So I might try to do that probably soon. So yeah, I refactored how I handle UI, and I added a simple pause menu and basic options menu. Fighters are now faster. That was just a matter of just going through all my ships and then, you know, setting them to be faster. So like my coalition arrowhead here, this is a fighter. So if we go to my inspector, you can see that max speed is now 850. It used to be something like 400 or something like that. So I basically doubled the speed of all the fighters, and it works a lot better. The only concern I have with it now is that if you have like a a target ship over here, and then you have like a fighter coming in, and the ship is moving, it gets into this thing where like the ship will kind of start rotating around it, and it won't ever hit it unless it has a beam, just because of how the ship inertia is applied to the projectiles. So I got some rough code working to make it to where the ship will try to use strafe to try to correct itself to get a more straight shot. So I need to implement that when it's intercepting. I did that when it's trying to return to the carrier, because it was just looping around the carrier like forever, which was lame. So I fixed it there. So if we go to my ship code here, all 1,588 lines of it, that's a lot of code. So let's go to AI state return to carrier. So another change I did was I started implementing this utility auto load. It's probably not the best way to do it, but I started noticing I have lots of repeat code. So for example, like if I'm trying to see if, you know, my ship is rotated to a certain angle or if it's facing a certain way, I was repeating a lot of the same code. So I started breaking that out into its own package. So right now I've only got 3 functions. I've got get relative angle by angle, and then the predict target ship position, which is what my turrets were using to to try to predict where the target would be. And this needs work. I'm not using this yet. It's not working how I want it to. I was going to try to use this to get my ships to also like predict where ships are going to be and like try to aim at them. But it wasn't working because this logic depended on projectile speed, which your projectile flies at 1 static speed, and ships don't do that. So none of these calculations mattered. So I'm still working on that. But the important thing is I got my angle code segmented out into a utility function that I can call from anywhere because it's an auto load. So I'm taking in the current rotation, the origin position, and then the target position. And what that does is that just gives us a target angle, and then we just call this get relative angle by relative angle, or get relative angle by angle function. So this was code I was using, but I didn't quite understand it. But I have a link here of where I got it. But from my understanding, this is just getting the relative difference. So for example, if I'm facing one direction and I need to rotate to my right to face something else, this just returns the quickest like angle difference between where you need to go. Because if I'm here and a ship is right here, I need to know that I have to turn right. So this is how I determine where I need to rotate. Otherwise, it'll just like rotate the other way and then go around to it, which is not what I want. So this was a way I found to do that. I need to break this out and like comment exactly what it does, because this is just a really ugly one-liner that is not very clear what it does, unless you're like a mathematician, which I'm not. So I got the link there, so I'll go through that at some point. But it's working. It's what I was using in my code before, so I copied and pasted it, and it's still working again. So fantastic. So let's go back to my ship code here. So during my AI state return to carrier, what I'm doing is I'm calling my rotate ship function, which uses some of that same stuff. And then I'm determining if we are facing our carrier, not out carrier, our carrier. And I'm making this absolute, so it's always going to be positive. And I'm just saying, hey, if the get relative angle by angle, if that is within 1 degree, then you're facing it. So you can accelerate and go forward. I also add this code to strafe if needed. So what this does is I'm also using that utility function, I'm doing get relative angle by angle. And so what I'm doing here is I'm taking in my rotation and then the angle of my velocity, which is my ship's inertia. So even though my ship may be facing this way, it's still drifting this way. So I need to get that difference between where my ship is facing and where I'm actually traveling. And then and I want to strafe to try to correct that. So that way this prevents the ship from like drifting like it's Tokyo Drift and flying around doing drift circles around ships. So I just need to implement something like this in my my code here. So I'm just saying, hey, if drift angle is greater than 0, that means that we're drifting right. We want to strafe to the left. So I'm just saying those here. If drift angle is less than 0, it's a negative value. That means that we're drifting left. We need to strafe to the right. So I'm doing that here. I need to also figure out, I don't like this accelerate, decelerate, strafe left, right code, because every time I set one, I'm also having to unset the other. And there's never a case where both of those should be true at the same time. So realistically, I should have only one variable that has 3 possible states. Now, in other languages, I would probably just make this like a nullable value. So, for example, I can make it a Boolean, but also have it be null. So a null is an absence of a value. So if, say for example, if I had like action accelerate, I can maybe have that be set to true. That means that we should be moving forward. If I set it to false, I could interpret that as we're going to decelerate, we're going to slow down. Or if I have it set to null, which is unset, it means that we're not doing anything. I don't think that I can do that in Godot, so I might just need to like make this a quick and dirty way that I can do it is I can convert it from a Boolean to a string and just have constants that define what my 3 possible values are. And I could eliminate those variables. So I can just have like, you know, action accelerate. I can have action strafe. I can have action turn. And I can have those set to be, you know, left or right or no or nothing or none. And then that way I can handle that. Because I'm kind of getting tired of setting two values every time I want to do one thing. So, yeah. Working on that. But anyway, that's some stuff that we can worry about later. So I might implement something like this in my AI state intercept code. So here I've got some code. I could... Yeah, I need to refactor this to use my new utility functions. And yeah, so I've got lots of repeat code that I need to weed out and simplify. But that'll come eventually. So let's see, what other changes I did? So fighters are now faster. We talked about our utility auto load I started. And the last change I made was I implemented a zoom lock on my zoom camera. So we go to my zoom camera here. This was a code that I largely lifted from a GD Quest tutorial, but I modified it to use my preferred camel case rather than the snake case convention that Godot prefers. Again, the reason why I prefer doing that is because I know that if I see camel case, it's code that I wrote, not built-in code. And yeah, so converted that, and then I have a variable here called lock zoom that I added. And basically all that does is that whenever I call set zoom level, I added a third optional parameter here that is lock. And this is defaulted to be false. So what I'm doing here is that if we call this and we lock it, I'm setting lock zoom to be true. And then let's see, I'm checking on my unhandled input here. When I check for my is action press, zoom in, or zoom out, which is my mouse wheel up or down. I'm just simply saying, hey, if we're not locked, then set the zoom level. But if we are locked, do nothing. So it won't actually respond to your scroll wheel when the zoom is locked. Now, how I unlock the zoom is on my tween that I create here. Let's see, where is it? Yeah, so we have this on ready. We have a tween that is attached, and then I connected that signal. There's a signal. This is on tween all completed. It will emit the signal, so I connected it to just set the zoom to be false. So that way, when I set a locked zoom, it won't let you zoom until that tween actually completes. And then from there, it unlocks it again, so you can change the zoom however you like. But I did that because there's specific cases where I don't want the player to zoom when I'm zooming in or zooming out. One, because it would look weird. So, for example, like when you first start the game and you have that initial zoom in, if the player immediately starts hitting the scroll wheel, it would like torque out. Like it would look really weird. So I stopped it from doing that. So that was it. That was the changes I've made. I've been working. I haven't worked too much on the game, obviously, but I've done a lot of thinking about it. So I'm almost to the point now. I'm starting to feel a lot better with UI, and I want to start implementing like the shipyard screen to where you can buy new ships, you can upgrade ships, you can swap out different weapons. So again, how I made my ships at the start is, let's go to one of my ships here. So you can see here on the left here, like I have these weapon slots here. So I can swap out those weapons for anything that is the right slot type. So if I have a light weapon slot, I can swap out any light weapon I want in there. It doesn't have to be this coalition light gun. I can add like maybe a synthocracy light cannon or maybe a laser beam or something else. So I can add those in. So if I have like a heavy weapon slot, I can add in a light weapon if I want to, but it'd be a waste of that slot, but you could do it. So I need to implement that. So I have an idea of how I want to handle that, but I don't know if I should port the game to Godot 4 first. I probably should. Because as of right now, I don't think there's too much stuff that I would have to refactor if I ported it now. I know that I would have to redo my tweens. I know that for sure. There's a few other tweaks that I would have to make, but I don't think it would be that big a deal. So I might just drop everything I'm doing. I think next episode I might just port it to Godot 4. But I'm not sure when I'll get a good chance to actually work on it a lot because, yeah, life is busy right now. So I haven't gotten a chance to do a lot of things. You probably noticed content has slowed down quite a bit, but whatever. I'll get there eventually. But anyway, that's what I wanted to show you. Thank you so much for watching. I appreciate it. And let me know your thoughts. I always appreciate feedback. And I'll see you in whatever video I make next.